Hello, I'm from Alluxio, and I'm here to talk about why you need more than just an application. You need infrastructure. This is going to be a little story around some evidence on how Alluxio software provides performance gains for running distributed query engines like Presto. It's amazing to me to talk about last decade. We're already halfway through this decade, but last decade, what did we do last decade? We were in the era of Hadoop, mostly, in terms of big data. So we ran these tightly coupled Hadoop clusters where we had to figure out what is Hadoop. It was this thing to store data. Oh yeah, then we can start to use the data. We queried it, right? So it was pretty tightly coupled storage and compute. A lot of it was on-prem, and then we figured out we can start to move to the cloud, perhaps, and build these data lakes. So we moved data from HDFS into data lakes. So we saw this beginning of the decoupling of compute and storage in that motion. But back then, the files were very large, typically. Hadoop was an append-only large block files, so we stored files in Hadoop that just accumulated row-based files. And when we got to using them, we realized they may not be formatted just quite right for analytics, so we started converting files. So anyway, this is a little history lesson of how we got here today. So yeah, I mentioned some of this, the aspects of the what we did. As we moved from last decade to today, we saw some loss in the data locality as we separated out the compute and storage. I always talk about storage like you pick a restaurant. There's three things. You can pick 2 out of 3. Good, fast, or cheap, right? And most people didn't think about the fast part, or they thought about the fast part, but you had to sacrifice performance versus price. So low cost. Most of the customers I talk to have one thing in common. They squirreled away petabytes of data over the last decade. And some of them are tens of petabytes, hundreds of petabytes of data. And the only way to do that is cost-effective storage. Again, now we're trying to consume it. How do we move from a low-cost storage platform to a consumption layer? If we built this data lake, how do we consume it? We also saw a change in the nature of the files, going from maybe millions of files that were relatively large to now we're seeing billions or tens of billions of files, much smaller in size, so different character. As we converted those into columnar formats or transforming these into consumable elements for modern applications, billions versus millions. So just changing the landscape. If we were on-prem, I often talk about, say, oh, the data access is free. Well, sort of. Once you buy the infrastructure, set up the infrastructure, yes, there's no extra cost to perhaps query or use your data, right? As we know in the cloud, it's very different. So we pay upfront for the infrastructure, and we have less concern over the ongoing cost of accessing the storage. So no API fees or no egress fees or transfer fees. If we are in the cloud, though, very different story. We love how cheap S3 storage or object storage is in the cloud. But once you start using it, you see these, even though it's like 0.005, that adds up, right? That adds up really quickly. We see access fees, everything you do. It's like, I remember watching this movie a while ago. It was like this old Popeye movie, and there's like the tax guy. Everything he did was a tax, right? So in the cloud, you do anything, you pay for it, right? There's no free anything, practically. So anyway, the point is, accessing storage, whether it's in single region, multi-region, or you try to pull it out of the cloud on premises. I talk about like the Roach Motel, free to get in, but you can't get out, right? So that's the cloud. Put your data there, but once you start to pull it back out, it costs money. Here's an example of a large profile processing like 10 petabytes a day. And if you look at the math, the arithmetic of accessing the data and or pulling this data out, it's it adds up. Like, so here's the math, right? If we had a petabyte of data and billions of requests at this low 0.004 rate times 365 days a year, $1.4 million to access that data. That's pretty chunky. Many customers that Alluxio sells to has this common theme. They put it in the cloud, they develop an application, they start consuming this at scale, and all of a sudden they're getting these large bills, right? So that's a problem for many customers. The cost and convenience all of a sudden got ridiculously out of balance. So what's the answer for that? We can pop in a cache layer. So easy to drop in this cache layer to take us from the left, where we're consuming data in the cloud, where multi-region is common in many environments, to let's eliminate this aspect of directly accessing from the cloud. A cache layer to move the data from the cloud to a cache layer to consume it locally. And this works whether you're in the cloud or on premises pulling out of cloud. So pull it out and consume it continuously from the cache until you don't need it anymore. So pretty simple model. And we see this simple diagram of the advantage of using a storage cache layer. Without a cache, you have query performance is two parts. There's the compute part, and then there's the data transfer part. And depending on your table size, the I/O part can be pretty significant part of this in terms of how you measure the total duration. We don't address the compute part, but we can help you get the I/O time reduced. First time you bring a file over to a cache, we call it a cache miss. We pull it out of the under storage or this data lake. So we see the first I/O access being about the same, but even so, we start to see, using Alluxio, the pattern of usage, we see even some improvement because we can start consuming it sooner in small chunks. Subsequent I/O requests and reusing this, of course, is greatly reduced by moving it to extremely fast storage layer, usually on some NVMe or SSD storage locally, as compared to pulling it out of S3, which doesn't stand for slow storage, but something else, right? Okay, anyway, simple idea. Add a cache. It provides a storage benefit, an access benefit to your application. Many of these applications that grew up in the Hadoop era run as a Java process, easy to drop in. We just add a client, an Alluxio client jar that essentially hijacks the meaning of HDFS or S3, points it to Alluxio. So easy to add, very non-disruptive in terms of the operational overhead. Again, leveraging local storage on NVMe or SSD. Version 2 used memory commonly because back then the storage or the prevalence of SSDs and NVMe's SSDs were less common as they are today. But in this day, now we tend to advocate NVMe storage. It's cheap, prevalent, and memory is more expensive. We have better uses for memory than putting files in memory or as a file store. So Alluxio Cache is a disk storage layer, providing this ephemeral, somewhat static caching environment for any application that uses Hadoop, for example. Since we're in the era of AI, we've bifurcated this idea of where can Alluxio fit. Traditional analytics frameworks, of course, are still very popular, whether it's Spark, Trino, Presto, or in the AI world, now we're seeing Python being the common language that is the basis of these modern frameworks, PyTorch, TensorFlow, and Ray. But the underlying needs are very similar. How do you feed the beast, right? How do you feed these engines to keep the storage or keep these applications at high utilization? So a common framework to serve both the traditional analytics as well now in the AI space. If we're building training or inference engines, we need to move data close to those applications as well. So a little more details on this large use case. Uber has lots of data. So you can do that. You can read here 50 petabytes of data, tons of queries, lots of locations, global access. They wanted or need a way to, again, take the data off these hard drive-oriented Hadoop clusters, put them into a cache layer to accelerate the consumption. Before and after, of course, before was slow, after speedy. So this is real data, real examples of a customer that saw huge benefits of popping Alluxio into their stack. Another set of data around just the use of this. We see in Hadoop clusters, oftentimes the name node is overwhelmed. That was a common aspect of all the data had to go through this master node, and we can eliminate some of these bottlenecks by moving away from the HadoopFS and moving into Alluxio. So the before and after, again, things that were blocked due to I/O performance to now it's nice and speedy with a cache layer. So you can read more about it. Certainly plenty of customers, maybe you've already experienced the same thing or using Alluxio, whether it's Presto, Trino, or Spark, or again, you're now building new applications with some kind of Python framework. Love to help you accelerate data access. And that's my speedy talk to move this conference along and provide some ideas on how to accelerate data access, query access, or model development. So thanks again for listening.